In this video, I want to introduce a component to you, an electronic component called operational amplifiers. Operational amplifiers are also sometimes referred to as op-amps. It's just a short form of operational amplifiers. These are very versatile um, components which can be used to make a variety of different uh, blocks that can do different functions. You could make amplifiers, you could make adders, subtractors, and many other uh, blocks out of op amps or using op amps. And that's why this is important. And what we'll do in this video and the following videos is we'll try to understand op amps and how we can make circuits using them. But for now, what I want to talk about is uh, what is an op amp, how does it look like, the symbol of an op amp, how many input-output terminals it has, and things of that kind. So the symbol for an op amp is basically a triangle, and it's got two inputs. One is called the non-inverting input, and this is called the inverting input. So let me just write those names. So this is the non-inverting input, and this is the inverting input. Now the non-inverting input is marked with the plus sign, and the inverting input is marked with the minus sign. And oftentimes what students do is they call this the positive input and they call this the negative input, and that is a very bad practice because there are two more pins in an op amp. One which is the positive power supply and another which is the negative power supply. And once you start calling these the positive input and the negative input, it's very easy to get confused with the positive power supply. So these pins are the power supply pins. So the power supply pins are the places where the op amp actually gets the power from to do whatever it's doing. So this is the negative power supply and this is the positive power supply. We have one more pin, which is of course the output. So that's the output. So an op amp is essentially a 5-terminal device. Two inputs, which are the non-inverting and the inverting inputs, two power supply lines, one the positive power supply and the negative power supply, and an output. When we buy op amps in the market, it's common to get op amps in packages. So they look something like this. It's a square package with some pins, and usually an op amp would have would be a 8-pin package. So I'm just drawing the pins here, and let me let me 4, 5, 6, 7, and 8. Right, so there are 8 pins in the input, but only 5 of them are usually connected. So we have pin 2 would be usually it would be the inverting input. Okay, pin 3 would be the non-inverting input. Pin 4 would be the negative power supply. And pin 6 would be the output. And pin 7 would be the positive power supply. Sometimes there would be additional features in these empty pins, pin 5, pin 8, or pin 1, but usually it's not there. So this is a single op amp. So in one package, you have a single op amp. Sometimes, just to kind of save space and give you more functionality, what manufacturers do is they take the same package, which is again a 8-pin package, and they put two op amps in it, right? And you can do that because if you think about two op amps, and if you make the same power supply go to both the op amps while having different inputs and different outputs, you can the total number of uh, pins is 8. So you have two inputs. The first op amp will be two inputs, one output. Okay, so that's the first op amp. And the second op amp also has two inputs and one output. Okay, so that's the second op amp, and that's the first op amp. And then you have two power supply pins. Power supply, right? And this power supply is shared between the first and the second. So this is shared between the two op amps, and that's why we can do with 8 pins. So for example, in this package, you could have this connected to positive power supply. This could be the negative power, and this could be the output of the first op amp. This could be the inverting input of the first op amp, and sometimes we write it as V in minus, and let me put 1 somewhere, so V in 1 minus, and this could be V in 1 plus, which is the non-inverting input. And on the other side, you could have this as output 2, this as the V in 2 minus, and this as V in 2 plus. So this is the non-inverting input, and this is the inverting input. And notice that I have said V in 2 plus, and because I have put this in, there is less probability of confusion with the positive power supply. Now this kind of a package where we have two op amps, right, is called a dual op amp. So in the same one package op amp, we have two op amps available to us. You could also make quad op amps. Usually quad op amps would have 14 pins, and they would have 4 op amps in the same package. 14 pins, and that is 4 op amps. And the idea basically is just to give us more functionality in less physical space.